we're looking at, Verisium is more like driver assist, right? I mean, think about how long we've taken to get to full self-driving. But what we have come out with is, the collision avoidance, lane keeping,
makes a difference.
Automatic cruise control and stuff like that, right? And and so Verisium kind of provides the same thing for verification engineers, where one of the examples that I've used is Verisium is helping when there's some sort of error. We talked about testing the microchip before we build it to make sure that it's correct. Well, when you're testing, you expect some of those tests to fail, right? Because that would highlight that there's a problem that needs to go fixed. That's the whole point. But engineers spend a lot of time figuring out, well, when something fails, why did it fail? What do I actually have to go fix? And if we can get them to, closer to the problem and save them, 2 or 3 hours of analysis or 2 or 3 hours of triage or whatever it is, and get them, within 20 or 30 minutes of the problem, we probably can't show them, oh, this is exactly the problem, or automatically go fix it. But what we can do is get them that much closer.
Hello, folks. Welcome to the future of electronics designed with Cadence, where we explore all the high-tech, cutting-edge technology that's involved here at Cadence Design Systems. And we're talking to some of the industry leaders to help us have fun with this and understand what's really going on out there. So we have all sorts of different topics, as you've seen from our previous episodes. And today I am so excited to welcome with us here Matt Graham, who is the Director of Product Engineering, which I have no idea what that means. Maybe you don't either, but we're going to find out today. Delighted to be here. Matt, welcome to the program. Good to have you here. Please tell us who you are, what you do at Cadence, and we're going to ask a lot of fun stuff today.
Thanks, Jeff. Glad to be here. Thanks for having me. So yeah, the product engineering something director, something in my title.
That's exactly what I said. I think
that's exactly pretty much exactly it. No, so I've been with Cadence for a long time, and as a result, I've accumulated a number of different sort of jobs. But right now, mostly responsible for how we're applying artificial intelligence, AI, and machine learning, ML, since we love short forms, to various, problems that our customers have. And as a product engineer, I kind of stand facing towards our customers, kind of technically focused on this AI and ML problem. My team and I should say, I've got a team of great folks all over the world, and then you sort of reflect that message back into our developers, the folks that are actually building the stuff that Cadence goes out and sells and solves those problems with. To sort of say, listen, our customer has this problem. Let's go figure out some way to solve it. And then once we've got a solution, go back to the customer and say, hey, Mr. Customer, we've got this great solution. We think you should try it, and maybe it'll help you out with whatever you're working on.
This is terrific. And I heard you, by the way, I heard you say oot a few times, which now you've given away the fact that you are clearly from up north of the United States, and you clearly played hockey and ate poutine while growing up. Am I correct?
Absolutely. The land of the hockey and the gravy on French fries. Absolutely. So I'm from the eastern part of Canada. I grew up there. Went to university for everybody else in the world, or college for Americans. Up there.
I've heard of that.
Yeah. I actually lived in the United States for a few years right after I graduated, but then back home the call of the frozen tundra was too strong. But most recently, and I've lived there for almost 18 years now. My 3 kids and my wife live in Ottawa, which is the eastern part of the country, sort of between Toronto and Montreal, depending on what your Canadian geography is like. Ottawa trivia for you: second coldest capital city in the world by average temperature.
Right?
So it is.
And what's the first?
I want to say Moscow. I'm going to get that wrong. Could be Reykjavik for all I know. But it's we had lots of ice and snow. But I recently relocated. Actually, I'm coming to you today from Cork in Ireland. And
is that right? I've been to Cork. Lovely town.
It is great. It's about 500,000 people. It's the second largest city in the Republic of Ireland, outside of Dublin. Kind of on the southeast coast, if you like. And Cadence has recently opened what we call our international headquarters here. So we're now about we're about 170 strong here in Cork. And so I relocated to help bring some folks on. I've been with Cadence a long time.
Now, when you say long time, give us a number.
So I've been with Cadence almost 20 years now.
20. Wow. So you were 5 or 6 when you started.
5 or 6, exactly. That's exactly right.
It's our early program that we start here. That's right.
Yeah, exactly. I'm celebrating my 29th birthday for the 15th time soon.
Congratulations.
But I recently relocated after being around for a while to Cork here. As we bring a bunch of new folks on to build up the site here, we need a bunch of sort of old and grizzled, if you like me, that sort of know all the ins and outs of Cadence to help bring that, the culture and the technology and all that. And so we're having all kinds of fun here in Cork. Great new site, interesting city for me, and a bit of an adventure for the family and I.
So here's people talk about AI and about machine learning as if it's like, oh yeah, AI, it's going to make the whole world better. So my question to you is, first of all, your official title is Product Engineering Group Director of Verisium. First of all, what is a Verisium? Where did it come from, and how do we make sure we use it properly? And do I need to put cream on it? What is a Verisium?
So Verisium is a platform of products that we announced last year. It was actually very cool. We had a little launch event at just near our headquarters in San Francisco, or outside of San Francisco, I should say, in San Jose.
I believe we're a certain football team. Just almost made it, but yes.
At our launch event, very cool for me, and I'm completely tangential from your question, Jeff, but I promise I'll get back there.
This podcast is about the future of electronics / tangential conversations is really what we're going to rename it.
Well, that's what we're going to get. So a personal sort of highlight for me, Cadence, has this recently announced, and I say recently in the last, however many, we haven't been for years and years anyway, announced partnership with McLaren F1. And we're a sponsor of their Formula One team and various other parts of McLaren racing. You can see in my background here, we've got some McLaren racing tchotchkes. And so at this launch event, we had the CEO of McLaren Racing, Zach Brown, and I got a chance to chat with Zach about racing and how McLaren uses advanced technology, and that's a whole other story for another podcast. How the stuff that Cadence does can impact racing, but anyway, that was our launch of the Verisium platform, and so Verisium is this platform of applications where we hope to apply artificial intelligence and machine learning and other similar advanced kind of technologies that are coming to the forefront, sort of coming of age, if you like, to the problem that some of the problems that Cadence customers have to solve in what we call pre-silicon verification for the 99.99% of the public, and maybe there's a few more nines there that maybe doesn't know what that is. Maybe I know you know this, Jeff, you're a super smart guy, but the concept of pre-silicon verification is that when a company like, I don't know, Samsung, let's say, wants to come out with a new chip that goes in, a cell phone or a monitor or whatever it is, one of the million cool products that they do, it costs a lot of money to sort of tool up to manufacture. And so they want to make sure that it's right. So before they ever build it, that is create the silicon, right? Create the actual silicon integrated circuit. They want to verify that it's, as best as they can tell, it's going to be right. And that's a big deal for them. And as your users, as I'm so used to dealing with software people that I'm now podcast people that aren't users, are the viewers?
Yes, listeners. They are. We're making this is interesting and fun. This is like the human side of what goes into your cell phone and why it's going to continue to work and never drop a call again. That's what we want to know.
Well, exactly. And that's the point. And so that's kind of, if you imagine all the things that a cell phone can do, as an example, it's impossible to exhaustively test that, right? You can't possibly go to every single combination. It's just not enough time and energy in the universe. And so, you got to be smart about what you want to test before. Our customers need to be smart. People like Samsung need to be smart about what they want to test before they ship it. And that's where we're going to try and apply AI and ML to that, or we are trying to apply AI and ML to that problem to be smarter about what our customers are going to test and how they're going to test it. So,
I mean, if you think about it, like you said, it costs millions of dollars to make these masks for semiconductor processing. And if machine learning could say, you know what, here's another test case. The Verisium platform allows a customer to test something and go, this phone is actually never going to drop a call. This tell me how machine learning, AI are used in self-driving or even assisted driving, how we're working with customers to make that better, right? Imagine the ability to have safer driving, or I just got my wife a car and it has assists on both sides of the car if we go out of the lane, which I tend to do, or because I'm from New York and lanes suggestions, and that technology. How is Cadence technology helping that in terms of our lives, safety, being more efficient with our time? Like you said, saving money before I go to manufacture, I know something is in good shape. This is kind of the exciting stuff that people can relate to. Even virtual headsets and all sorts of things, and VR. We live in a virtual world at times.
Absolutely. I'm sure some of your other podcast guests have talked about this as well. But, Cadence, we're enabling stuff all over, anything that's got a microchip in it has been touched by Cadence somewhere. And it's no different with the Verisium platform and the part of Cadence that I work with, that this pre-silicon verification, the system verification group, technically, for those of you scoring at home. But the types of customers we work with, everything from pacemakers to, like you say, collision avoidance system for cars, right. Avionics and navigation for aircraft, all kinds of different stuff, as well as consumer, PlayStations and cell phones and who knows what else. And the way that Verisium is helping is and the way I think AI is helping in general, is to help automate some of the tasks that engineers need to do today, or computer scientists, or whoever's working on designing these chips, that are repetitive, but also that need to consume a sort of a large amount of data. So let me try and give you a little example of
like
that.
My children's social media feed.
Well, exactly.
Yeah, that's a lot of data. And repetitive.
It is a lot of repetitive data. I know I'm assuming you have teenagers as well, or
I do.
Or
I have late 20s and teenagers, and yes.
So I have teenagers as well. So they're on it.
Yes.
They're providing the big data.
That's right. That's right.
So what we've, if you step back and think about, AI is artificial intelligence and ML is machine learning. Well, the artificial intelligence means that it was beget by intelligence, right? That's what we can provide.
Something that we have none of. So
it depends on who you ask on the day.
Yes.
So what the machines are good at is analyzing a lot of information and doing something relatively simple to it. Whereas what humans are good at is doing something really, really complex to like 3 or 4 or 5 pieces of information. If you ask my wife, it's a lot less than 3 or 4 or 5 that I can consume at any one time. But
that's right.
But what we're good at is making those really complex relations. Like what happens when I take my cell phone away from my kid. That's a pretty complex relation.
That's right.
That has repercussions for months. But the machines are good at, well, let's look at 10,000 pieces or 100,000 or millions of pieces of information and just sort of sift those down so that we can get down to 4 or 5 key pieces of information that a human can then make a decision about. And there's an everyday example that everybody has got in their life, and that is online searches and things like Google. Anybody that's your age, my age, even a little bit younger remembers 10 years ago, you type some term into Google, that's you're spinning the wheel, right? You might get something useful back, you might get something totally off the wall. And you had to be careful what you searched for, right? Because if you search for certain terms at work, you never knew what you were going to get. But now, Google has started to apply this AI and ML in the background. And this is all public. I mean, this is, very, very out there and is interesting to read about for me as a nerd.
Yeah, you didn't give off that vibe at all.
Hard to tell. Yeah, I know. But you get back information that's really closely related to something that you're actually, to what you were actually searching for. Now, Google doesn't take you straight to that page. I know they've got the "I'm feeling lucky" button, but that's another podcast too. But it'll give you back, and in the top 5 or 6, it says, okay, Mr. Human, here's 5 or 6 probably that are most likely, or Mrs. Human, let's be equal opportunity. It'll give you back those 5 or 6 results, and now you can pick from those 5 or 6 and say one of these is most likely. And how often is it with Google that it's in those top 5 or 6 that you pick something out? They didn't choose the top 1 for you. For me anyway, it's almost never the top 1, but it's the top 5 or 6 are pretty good.
I agree.
Usually. So, and that's what we're trying to do as well for verification users.
And this is so great because people always ask, what do you do at Cadence, or if your kids say, Dad, what do you do? Mom, what do you do for work? And you have to explain to them, or you're at a party and they ask you, what makes it interesting, right? We go to so many tech conferences where everybody's talking about this is the best in class. Talk to me about life. Talk to me about something practical, right? How is AI going to make our lives better? I want to make sure my call doesn't get dropped. I'm on the internet at home. I'm on this video call. We're having a conversation. You're in Cork Island, right? You took a shower with Irish Spring. Now you're at the office. You're doing something that's going to change the world. A Verisium platform, Cadence AI and ML. You tell your kids how you're changing the world. What would you tell them?
Oh, that's a good question. I've always thought, how do I explain my job to my wife or to my grandmother, right? Outside of, well, he works with computers.
Right.
And really it's the amount of, I guess, advanced technology, microelectronics, whatever, in our world is growing every day, right? And so in everything, not only in cell phones getting smarter and better and whatever, but as I mentioned, all those other areas, cars and planes and whatever. And the number of engineers, the number of computer scientists that are enabling those isn't growing as fast as the number of microchips, the amount of electronics. And so really, if we're going to keep pace, if we're going to keep that level of advancement where we can, make planes safer, make cars drive, fewer car crashes, make pacemakers better, improve health devices so people are living longer and living more productive, building supercomputers so that we can figure out, how to cure cancer and find a solution for Alzheimer's and all these other things. We need to be able to improve the productivity of the engineers and computer scientists that are making all of those, because there's not enough of them. We're not training enough. There's not enough people in the world for that, that have those capabilities and can get into that. And so this is where, getting back to your question, how am I making the world better? This is where the Verisium platforms really focuses on the productivity of the engineers and computer scientists in our customers, making those devices, designing those devices, making it so that, if it takes a year and a half to bring out, a new design for a guidance system on an airplane or an anti-collision system in a car, we want to bring that down from 18 months and 100 engineers to 12 months and 75 engineers.
Right.
Not so we can get rid of the other 25 engineers, but they can go off and solve another problem.
To do more efficient, solve other problems. Exactly.
Absolutely.
And that's part of the challenge too. People think, well, machines take over. And I never believe they do. I think it'll allow us to open up to other problems. Well, Verisium, since it utilizes so much AI and ML, is there a potential to do away with the need for verification engineers?
Yeah, Jeff, I mean, it's an interesting question, and it is where everybody goes when they think about AI, because, science fiction and all that, right? The Matrix and this kind of stuff. But, not in my, exactly. Not in my lifetime. I certainly not in my career. We're looking at, Verisium is more like driver assist, right? I mean, think about how long we've taken to get to full self-driving, but what we have come out with is, the collision avoidance, lane keeping,
makes a difference.
Automatic cruise control and stuff like that, right? And and so Verisium kind of provides the same thing for verification engineers, where if one of the examples that I've used is, Verisium is helping when there's some sort of error. We talked about testing the microchip before we build it to make sure that it's correct. Well, when you're testing, you expect some of those tests to fail, right? Because that would highlight that there's a problem that needs to go fixed. That's the whole point. But engineers spend a lot of time figuring out, well, when something fails, why did it fail? What do I actually have to go fix? And if we can get them to, closer to the problem and save them, 2 or 3 hours of analysis or 2 or 3 hours of triage or whatever it is, and get them, within 20 or 30 minutes of the problem, we probably can't show them, oh, this is exactly the problem, or automatically go fix it.
Right.
But what we can do is get them that much closer. Think about your car, right? You take your car to the mechanic and you go, it's making a noise. And he goes, okay, well, I'm going to start by taking the tires off. But if we had, if there was a Verisium for auto mechanics, it would say, hey, it's not the tires, it's not the brakes, it's not the engine, it's not the exhaust, it's the transmission. Start at the transmission. And that would help the auto mechanic say, oh, I don't have to spend half an hour or an hour driving the car around or figuring out,
right.
I can go straight to the transmission. So Verisium wants to do that same thing, right? Your microchip test has failed. Go straight to the whatever part of the chip it might be and start looking there.
That's great. And I love the concept. That sound you made, my car actually made that sound yesterday. But
Oh man, that sounds like an expensive
sounded
sound.
somewhat Canadian. But and then I got to make sure I have the auto repair person that is not looking to go through everything and charge me per hour,
Yeah,
right? So
yeah, exactly.
So that's the hope, right? I even bought one of those ODB readers to read the code to see if I could fix it myself because I'm a nerd as well.
Yeah, absolutely. I mean, you gotta get in there. You gotta dig in, get your hands dirty, right?
That's right.
What,
I love it.
So it makes it fun.
But it's really an exciting field if you think about taking technology. Everybody, has a life outside of work, and I always find it interesting to think that you're up there. Do you see any way of applying machine learning and AI to the NHL, to the National Hockey League?
Oh
and,
man,
improving the puck speed.
Don't get me started on metrics and what is it, advanced analytics and all that other kind of stuff.
How to win a boxing and a hockey fight. I mean, could you put the mechanics into that? That's what I'd like to know.
Yeah, there you go.
Or how many beers to drink at the game before you measure before your behavior starts to get you thrown out or something.
Yeah, exactly. So there's actually, believe it or not, there is some legitimate stuff. One is the stick design. Now, this is true for almost any sport now, but if anything with a stick or a bat or a racket,
everybody talks about the hockey stick. No, the actual stick they're used for hockey.
Exactly. The actual stick. So they're doing a bunch of research on and I know that AI and ML are used in this process on the weave of the, I guess it's carbon or composite or whatever. The more the stick bends, of course, the more then there's the rebound of not the rebound, but whatever you call that, when you bend the stick and then it whips through the puck, right. And that's a faster and more powerful and blah 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 and all this other kind of stuff. So there's a bunch of
this is real science.
Yeah, it's real science, which is why the guys are shooting harder and harder and harder. And then the other thing is the ice itself. And you wouldn't believe this, but I've been seeing this. My kids play hockey as all Canadian kids do. Yeah, exactly. But now in the arenas, the Zamboni, the machine for resurfacing the ice, now is you can see there's like some sort of sensor tower thing on the part that actually drags along the ice, and it's like raising and lowering sort of automatically. And I asked the guy, so it learns where the dips and the
ice,
where the cuts are going to be, like in front of the net where there's more activity.
That hockey stick design actually goes back to, you brought up something, you talked about the McLaren partnership we have and CFD, right?
Yep.
Maybe you could share what that means and the actual meaning of CFD, right? And it's not, and how that whole concept of designing a hockey stick and improving the aerodynamics of an automobile to make it go faster, more efficiently, or a phone to make sure it works. Those are all, we have part of the, connected to the Verisium platform, but part of the whole Cadence toolset actually has AI and ML that assists in that kind of stuff.
Yeah, absolutely. So I am a total car nerd. And so I find this stuff fascinating. So you said CFD. So recently we legalized cannabis in Canada. And
that's what CFD
sounds like something you get at the vape. No, right. CFD is computational fluid dynamics, actually.
Computational fluid dynamics, which
so that's like the ability for a computer to simulate what happens when something, an object like a car, goes through a fluid like air, which we don't think of air as a fluid, but it behaves like a fluid, or a boat through water and things. And so Cadence has partnerships actually with two things that are really cool. Now, I'm not a big boat guy, but we're also partnered with the one of the America's Cup teams. I'm going to say New Zealand, and if I get that wrong, we can cut this out, or you can leave it in, and you can say that, Matt, you're very wrong. For designing their boat, but the CFD software is basically simulating what happens, when you pass that object, whatever it is, through air. And so the guys at McLaren are using that to figure out how to make their car more aerodynamically efficient, right?
So cool.
Before Zach Brown, actually, this ties back to Verisium at the Verisium
CEO,
event.
The president of
the president and CEO McLaren Racing, exactly. He was telling us that they now have a very strict cost cap in Formula One. So they're not allowed to, 20 years ago, they would build 10 different wings that go on the front of the car, right? To help with the grip, push the car down into the ground. They'd build 10, take them to the racetrack, drive around, test them all, get out of the car. The driver says, this one's the best. Or they look at the stopwatch and go, yep, when we had that one on, we went the fastest.
So cool.
They're not allowed to do that anymore. They've got to simulate, just like our microchip customers, they've got to simulate all these different wings using CFD software ahead of time, and then pick the best one build that one and take that to the race because that's all the money they've got. They've, you know,
Wow.
it's still huge amounts of money, obviously,
Sure,
but you know,
but
they
how
don't
cool.
have. Yeah, no, it's very. And he was saying that so that you know that they are very, you know, keen users of this kind of simulation technology, whether it's for, you know, the electronics on the car, or the aerodynamics, or whatever. So that's
I think,
very cool.
I mean, think about how cool that is that Cadence is actually working with Formula One racing. Maybe we'll be at, no matter what, we're at NASCAR. Wouldn't that be kind of cool, right? We got to remake the legend of Bobby.
Yeah, exactly. That is the thing. I don't know what to do with my hands. Right,
Talladega Nights. We got to redo that movie
exactly.
with Cadence as a sponsor there. I mean, think about that, or think about we could approach all the Olympic runners and do a simulation with computational fluid dynamics and show them how to run faster. We could, all athletes. My son plays basketball, right? Or you think about football players, or excuse me, American football players.
Yeah.
And or that was that soccer? Is that a sport? But
Sure.
or cricket. You know what I hear when I'm on stage most of the time, and so these kind of things we could even imagine taking that technology, everyday world things that we all do. I love the concept of driving better, driving safer, and Cadence is having a hand in all that. And maybe we could make something where we relate to everybody. We touch everybody's the things that we all do every day in life, and it all starts with, remember, as you said to me, it all starts with Verisium, right? Doesn't it?
Well, sure. Yeah, I don't know if it all starts with Verisium. I don't have that big an ego, maybe, but
it all ends with Verisium.
Sure,
before you
maybe.
go to tape out.
Yeah, but no, absolutely. And actually, one of the, you know, you mentioned that, wouldn't it be cool for you know, Cadence to touch all these pieces of everyday life? And that's the it's like people don't appreciate. I think we do. I think we touch a lot of things. You know, on not a lot of things, almost all things. You know, we're at this kind of you know, we're inside the stuff that's inside the stuff that you use every day. You know, I mean, that's your
kind of smartwatch, your smartphone,
cool.
Your smart. The only thing that aren't smart are the people, I think, at this point. Because
exactly. I mean, we joke, but I mean, you know, you and I are both, I think we share this, in that, you know, it's easiest to make ourselves the butt of a joke. But in all seriousness, you know, the people at Cadence are, you know, the smartest people I know. Yep. You know, and some of the nicest people I know. You know, the people at Cadence. I mean, they're it's such a fun place, such an interesting place to work, and such a great community. The site that I'm at in Cork now, our new international headquarters, is just, you know, so vibrant, right in the city center of Cork, which is so cool. You know, to get to come to work every day, and, you know, the little harbor's just out front here. I say little harbor; it's a, you know, proper working harbor is out front of the building. But, you know, what's going on inside the building is super cool as well. It's you know, it's just such an interesting and exciting culture to be part of, and think we're then touching all of those things from, you know, as you've mentioned a couple of times, everything from consumer electronics and you know, smartphones and whatever, through cars and all sorts. You know, it's getting easier and easier to explain to my wife, what is it that you do?
That's right. Well, you know, now what I'm thinking is that, you know, you grew up in Canada, you went to school in Canada, then you came to the U.S., now you're back in Canada, then you went to Cork, Ireland. I'm sensing there's perhaps a warrant out for you when you're trying to run. Do you plan to come back to Canada, or are you there?
So you know, never
opening up a seat in you know, you opened up something over there.
No, never. You know, you never say never to anything. But I don't. I mean, the plan.
Did your whole family relocate? Your whole family relocated?
Yeah. Well, we're in the process of. It's been. I'm just here a short time so far, but yeah, they'll all relocate. We'll see after a couple of years. I mean, again, I mentioned, you know, Cadence being a great company. They've been super nice with me and flexible about that, and so I'm looking. You know, we may end up here forever. I mean, my kids are redhead; they'll fit right in, as I mentioned. But
how wonderful! And it's great. You have all these opportunities opened up to you through Cadence, and you came to Cadence through an acquisition many years ago. Is that correct?
Yeah. I worked for a little company called Vericity, which did something that was very Verisium-like, something called SpecMan, which was you know, started with this idea of, hey, maybe we can randomly choose what we test with some, you know, intelligent parameters. In ICs, and that was it was about 200 people. It was an Israeli company, actually, which, by the way, anybody listening, highly recommend Israel. I've been many times.
It's great.
It's such a fun trip.
It is absolutely an amazing place. Absolutely.
Very, very cool place to visit. Highly recommend. But and yeah, that little company that got bought by Cadence, gosh, almost it was 2005. So yeah, we're getting on for 20 years ago. You know, joined into to Cadence through that acquisition, and have been through, been part of adding a few other acquisitions into Cadence, and now bounced around different roles. I was an application engineer for a while.
So you
now in Cork.
You have the foundation, the technical foundation. As an engineer, you have family, you have teenagers, which are consumers of a lot of the technology that we produce. And you watch lots of acquisitions. You think about Rocketick, another Israeli company that's part of our Excellium, which is all part of the whole Verisium platform. So we've got a lot of the pieces all together. We could work with the excitement of working with Formula One racing. We could improve car efficiency. We could make sure that the power performance and area on the chips and in your phones are perform better. We all want to be smarter. We all want to manage, whether we're driving an electric car or a gasoline car, we want it to be more fuel efficient. The technology's in there. So what thoughts do you want to leave with our listeners today as far as AI and ML? And it's not only here to stay, it's actively involved. We're always improving our lives, our health sciences. What message would you like to leave our viewers?
At Cadence, we're working on this, the idea of applying AI and ML to microchip design in general, with the goal of, improving the idea of productivity, that end to end. Can we do more with the amount of people we have today and make the people better in the same way that advanced lane departure and collision avoidance in cars are making people better and safer drivers? Can we make the computer scientists and engineers that are using Cadence products, more productive and really able to, contribute more in their field, wherever that is, be it, cell phones or pacemakers or everything in between. The Verisium platform is, something that's near and dear to my heart. That's on the verification side. It's one of the ways, one of the pieces of software and sets of tools that Cadence is bringing forth to our customers in the microelectronics industry to help them, make sure that their devices are correct and safe and high quality. And again, their engineers have the highest productivity they can and bring all of the, not only interesting, but important capabilities and products and features to market, in sort of the best way possible.
So everyone, thank you all for listening today. It was a great day. We love talking about the future of electronics design with Cadence. For more information on what we discussed today, please go to our website, cadence.com/go/Verisium. You'll learn so much more about Verisium and the different projects that Matt shared today. And we look forward to seeing you on our next podcast, where we have another exciting idea of what we're doing in the world of electronics and cutting edge of technology. Join us. We look forward to talking to you and having a few laughs along the way. And remember, please do laugh a little. It's good for you. Have a great day.
Thanks very much, Jeff. Thanks for having me.